Hi, it's Paul Anderson, and in this video series, I'm going to be talking about the next generation science standards. When you see the word standards, you might think about the Common Core state standards. Those are a group of standards in the areas of mathematics and English language arts that are going to guide schools over the next decade. They do contain a science component, but it's just a literacy component. They're not the science standards. The next generation science standards will be released this spring. And when they are released, they're going to give science teachers guidance, not only what they should be teaching, but how they should be teaching it. And the reason I love the next generation science standards is that they're built on a wonderful foundation in three general areas. And this foundation, called the K-12 Science Framework, is amazing. It was developed by a group made up of both scientists, and there were a number of Nobel laureates on that group, and science educators. And basically what they came up with was a core, these core concepts that you need to have to be scientifically literate. In other words, to be a scientifically literate member of society. And so if you're interested in science at all, like me, you'll be interested in the framework. But quick disclaimer, I didn't have anything to do with the formation of these standards or in the drafts of these standards. I'm simply a teacher who's interested in this framework and wanted to share that interest with you. And so here's a citation to the standards. They were developed by the National Research Council, which is essentially the working arm of the National Academy of Sciences and Engineering. If you're interested, you could go to this website, nextgenscience.org. You can download the K-12 Science Framework. It's basically 400 pages, and that's what I'm going to base this video series on. And so I love it, and I want to share some of that love with you. And so basically, it's in three areas, in the areas of practice, concepts, and ideas. And so they've come up with 8 science and engineering practices, 7 cross-cutting concepts, 44 disciplinary core ideas, and those are going to be in the areas of physical science, life science, earth and space science, and finally engineering, technology, and applications of science. And so if you add all that up and include this video, that's going to be 60 total videos that I'm going to make that cover the K-12 Science Framework. And so I hope you're with me as we tour this K-12 framework, because I know I've learned a bunch already, and I hope you can learn some with me as well. And so I want to go through these 3 general areas and give you a taste of what's to come. First is the area of science and engineering practices. You'll notice that engineering is a big part of these new standards. And the reason why is that engineering is really the application of science. And so the practices are a combination of both knowledge and skills. In other words, what is required to do science or to do engineering. And so an example of practice could be practice number 3. That's the development of using models. And so in order to work as a scientist, you have to be able to do that. And our students should be doing that as well, all the way from elementary through high school and on to college. And so let me give you a real world application of this practice. If you were with me in August, you were eagerly awaiting signals from Mars Curiosity, this giant laboratory that had landed on the surface of Mars. And the way it landed was amazing. It actually was dropped from a rocket crane and lowered kind of onto the surface. But in order to do that, the scientists and engineers at NASA had to develop a number of different models to test this out to see if it would actually work. And then finally, in August, it landed. And you can see these guys are super excited about that. And so that would be a practice, the ability to develop and use models. But they're not always physical models. Sometimes they're math. Sometimes they're computational models. Next is the area of cross-cutting concepts, and there are going to be 7 of those. These are going to be fundamental concepts, and they're going to bridge all the ideas. In other words, you could have a cross-cutting concept in the life sciences or in the earth sciences or in engineering, and it's going to essentially be the same thing. And there are 7 of these concepts they came up with. Number 2 could be cause and effect, or is cause and effect, or it's looking at mechanism and explanation. So to give you an example of that, in the sciences, it was a while ago, we had no idea how infectious disease worked, how I could transmit one disease from one person to another. And it was beyond belief that there could be some microorganism that could pass that. But the work of scientists kind of figured this out. This is Louis Pasteur, and you may know Louis Pasteur from the word pasteurization, but he was one of the scientists that figured out how infectious disease worked. And let me explain the science that he did. He developed something called a Pasteur flask. And what he could do was take a broth and he could boil within that flask. Think of it as like chicken broth. So he would boil it within there. He would then leave this neck of the tube with some water down here. And then on the other one, he would simply break it off. And what he found is that this one right here, where there was no contamination, in other words, there were no microorganisms that were able to make their way in, there was no spoilage, there was no contamination. But in the one where he broke the lid off, there was contamination. So through the hard work of scientists like this, they were able to look at the cause and the effect and relate that together. But again, that's not only going to be in the life sciences, we'd find that everywhere. And finally, we get to the disciplinary core ideas. Again, those are in the areas of life, physical, earth, and then engineering. And basically, that's going to be the content. But the nice thing about the state standards is that they're going to give you a progression. They're going to teach you how to teach that and how to step students through that material. And so, for example, this is Life Science 1. So this is Disciplinary Core Idea 1D on information processing. And so in the elementary level, you're going to teach students that they have parts of their body that they can use to collect information, like their eyes take in light, their ears take in sound, and their hand can take in touch and also sense temperature. But then as you work through middle school and on to high school, you're going to increase that information around this core idea. So to the point where you're in high school, you're going to be talking about the brain and how those signals are received in the brain and where they go in the brain, how we form memories and how we form actions based on that. And as you look at my videos, I'm going to have little icons in the corner of each of these videos that show you what students should understand. So this is what students should be able to understand by the time they graduate high school. And so those are the core ideas. These are the standards. Again, there are going to be about 60 of these videos that walk you through it. It's going to be a long journey, but hopefully it's going to be a fun journey, and I hope you come along with me, and I hope that was helpful.